Find the equation of plane which contains line of intersection of the planes. See, these two planes are given. So a plane passing from intersection of these two planes and which is a parallel to this third plane that we require. So say here we are given vector equations of plane. Now converting this into Cartesian form, its Cartesian form will be, considering vector r is xi plus yj plus zk. So this will be x into 1, that is x, plus y into 2, that is 2y, plus z into 3, 3z, minus 4 equal to 0. This is equation 1. Second equation is vector r dot 2i plus j minus k plus 5 is 0. Converting this into Cartesian form, 2x plus y minus z plus 5 equal to 0. These are given planes. So equation of plane which contains line of intersection of these two planes, containing line of intersection of these planes 1 and 2, it can be written as, that means plane passing from intersection of these two planes, that is by result x plus 2y plus 3z minus 4 plus lambda times, this equation is 2x plus y minus z plus 5 equal to 0, where lambda is any real, and for a required plane this is some lambda, for particular lambda belonging to R. Let me say this is equation 3. Now this plane is perpendicular to that plane. So that means dot product of normal to this plane and normal to that plane is 0. So now to find here normal, let me put this in form. To find normal, we put this in standard form. So 1x plus 2 lambda times x, that is 1x plus 2 lambda times x. We are interested in knowing the coefficients of x, y, z. So 1 plus 2 lambda times x plus 2 plus lambda times y, this is 2y, this is lambda y, plus 3 minus lambda times z, 3z minus lambda z, then minus 4 plus 5 lambda, that is 5 lambda minus 4 equal to 0. And now you can see that here this is ax plus by plus cz plus d equal to 0. So normal to this plane is, let me say vector n1. So it is 1 plus 2 lambda times I plus 2 plus lambda times j plus 3 minus lambda times vector k. This is normal to this plane. Now normal to that plane, normal to this plane r vector r dot 5 times vector I plus 3 times vector j minus 6 times vector k plus 8 equal to 0 is. Here normal is, let me say this is vector n2. Vector n2 is 5i plus 3j minus 6k. Vector r dot vector n plus d is 0. So here this is normal to the second plane. Now here vector n dot vector n2 dot product of these two will be 0, because plane 3 and this given plane are perpendicular, because required plane is perpendicular to this plane. This is the reason. So therefore, solving this equation we can find value of lambda. Now vector n1, this is vector n1, this is vector n2. Now we are taking a dot product of these two vectors. So see 1 plus 2 lambda into 5, that is 5 into 1 plus 2 lambda, then plus 2 plus lambda into 3, that is 3 into 2 plus lambda, then 3 minus lambda into minus 6, so minus 6 into 3 minus lambda, this is 0, dot product is 0. Therefore 5 plus 10 lambda plus 6 plus 3 lambda minus 18 plus 6 lambda is 0. So 3 lambda plus 6 lambda is plus 10 lambda. So total is 16 plus 3 19 lambda. 5 plus 6 11. 11 minus 18 is minus 7, taking on that side plus 7. So lambda is 7 by 19. This value we are putting in this form. So putting in 3, x plus 2y plus 3z minus 4 plus lambda is 7 by 19 into 2x plus y minus z plus 5 is 0. That is 19 into 1, that is 19x plus 19 into 2, that is 38y, 19 into 3 57z, 19 into 4 76 plus 14x plus 7y minus 7z plus 35 is 0. Therefore 19x plus 14x, that is 33x, 38y plus 7y, that is 45y, 57z minus 7z, that is 50z, minus 76 plus 35, that is 6 minus 5 is 1, 7 minus 3 is 4, minus 41 equal to 0. So this is required equation of plane. Its vector form is, we can show also this final answer in vector form, that is vector r dot 33i plus 45j plus 50k minus 41 equal to 0. So this is answer. Find the vector equation of the line passing through 1, 2, 3 and parallel to the planes. Say here two planes are given. We want equation of line A point on line is given. So to find equation, we need its direction showing vector. So we suppose that let the required line be parallel to, let me take vector B. Suppose vector B is Li Mj plus Nk. L, M, N are direction ratios of vector which is parallel to that line. So equation of line will be, so vector equation of line will be vector R is equal to, say here this is given point, so position vector of a point on line, it will be 1i plus 2j plus 3k. So adding that statement, then we are putting equation of line. So this is a direction showing vector, and given that line passes through point 1, 2, 3. So vector A is I plus 2j plus 3k. So vector equation of line is vector R is I plus 2j plus 3k, that is vector A, plus lambda times vector B, this is B. Suppose this is required equation in which these number L, M, N are unknown. So this whole procedure, now we are doing calculation to find L, M and N. Now see, here line is, it is parallel to this plane. It is parallel to this vector. Line is parallel to this one, this plane. Line is parallel to plane. Now see, whenever a line is, say this is the line, any line is parallel to any plane, then what will happen? Normal to this plane and a vector parallel to this line, both will be perpendicular. When line is parallel to plane, then normal to the plane and line will be perpendicular. So dot product of normal and vector B, it will be 0. So therefore, because this is parallel to this plane, therefore dot product of N, which is normal to this plane, whose normal is I minus j plus 2k. So therefore dot product of normal and vector parallel to line, it will be 0. Here I have explained in diagram. So therefore dot product of this vector n, let me say vector n1, because we are having such two planes with these given two planes, line is parallel. So this is vector n1 dot, this is vector b, dot product is 0. So taking dot product of these two vectors, L into 1 is L, M into minus 1 is minus M, N into 2 is 2n equal to 0. This is, let me say, equation 2. Now we are also given that a line is parallel to this another plane. Also given that line is parallel to, required line is parallel to this second plane. Whose normal is, let me say normal is vector n2. So normal of this plane is 3i plus j plus k. So line is a parallel to another plane. So another plane, it can be something like this. It can be like this. So if there is a line in the space, then if you imagine this plane is also a plane parallel to this line. You can imagine this plane parallel to this line, because we are doing in 3 dimension. So imagine this line in the space. This plane is parallel to this line. Plane in this level is also parallel to this line. You can imagine this plane, it is also parallel to this line. So many planes, but every time normal to the plane, it will be perpendicular to line. So here in this case also, normal to this plane and direction of line, its dot product is 0. Therefore 3i plus j plus k, we calculate dot product. This is n2, this is vector b. So L into 3, that is 3L, m into 1, that is m, n into 1, that is n, equal to 0. So this is equation 3. Now we solve equation 2 and equation 3. So adding 2 and 3, so this is 2, this is 3. Adding them, this will cancel. 4L plus 3n is 0. So L is minus 3n by 4. L in terms of n. Putting this value in equation 3, putting in 3 into L, that is minus 9n by 4 plus m plus n is 0. So we can get value of m. Value of L is obtained. Now going to get value of n. Therefore m is equal to 9n by 4 minus n. So m is equal to 9 minus 4, 5n by 4. So this value, now value of LMN, we are putting these values in equation 1. Putting value in equation 1, we have vector R is I plus 2j plus 3k plus lambda times Li. What is L? L is minus 3n by 4 times I. Then m plus mj. What is m? 5n by 4 times j. This is m. L and m in terms of n, and keep n as it is, n times k, where lambda belongs to R. Here lambda is any real. This means, now putting this in simple form, vector R is I plus 2j plus 3k plus. Now see, here n is common and we are taking 4 LCM. So n taken out, 4 taken out, so minus 3i plus 5n, 5j, 3i, 5j, see n by 4 taken out, plus 4k, here n is also real, lambda is also real. So here L, M, N, these are scalars, and the relation between L, M, N, here we have found M in terms of N, L in terms of N. You can choose any real number as value of N. You can put n equal to 1, you can put n equal to 1 crore, whatever you put here, same will be here, and same value will be here, L, M, N. So n is any real, n can be taken in this calculation, n is any real, lambda is also real, so real into real is a new real. Now to put this in better form, I am taking minus common. Taking minus common, this is 3i minus 5j minus 4k. That is, vector r is I plus 2j plus 3k. And suppose this number is mu, where mu is any real, this is any real. So this is vector equation of required line. Find vector equation of line passing through 1, 2, minus 4. A point on line is given and the line is perpendicular to these two lines. Say here, to find vector equation of line, because a point is given, we want its direction, means a vector parallel to required line. So again, suppose that direction of line B, let me take vector B, it is Li plus Mj plus Nk. This is the direction of required line. That means line is in the direction of this vector, or line is parallel to this vector, and directions of given lines are, let me take from first equation, here observe numbers in denominator, here direction ratios are 3, minus 16, 7. So direction of second line is, it can be taken as vector B1 equal to 3i minus 16j plus 7k, and direction ratios of second line are 3, 8, minus 5. So its direction can be defined as vector B2 is 3i plus 8j minus 5k. Now because this line is perpendicular to these both lines, so this will be perpendicular to this vector as well as this will be perpendicular to this vector, because required line is perpendicular to given both the lines. Therefore dot product of B bar with B1 is 0 and dot product of vector b with b2 is 0. So therefore 3 taking dot product of these two vectors, L into 3, that is 3L, m into minus 16, so minus 16m, n into 7, 7k is 0, and its dot product with this vector, so L into 3, that is 3L, 8m minus 5n equal to 0. So we have these two equations in terms of L and equations in Lm and K. Sorry, here I should keep n, 7n, 7n, here minus 5n, it's okay. Now we solve these two equations. So solving these equations, so this equation is 3L minus 16m plus 7n is 0. This equation is 3L plus 8m minus 5n is 0. Now taking subtraction here, minus minus plus, so this will be cancelled. This is minus 24m plus 12m is 0. So 24m is 12m. We are getting values of L and m in terms of n. So m is equal to 1 by 2n. Now this value of m we are putting in any one of these two equations. So let me put in this equation. So putting in the second equation, 3L plus 8 into m minus 5n is 0. Therefore 3L is 5n minus 4n. This will be 4n. So 3L is 5 minus 4, 1n. So L is equal to n by 3. So L is n by 3, m is n by 2, and n is n. N is any real. So taking help of n, small n, we can have infinite many such vectors showing the direction of required line. Now these values L, M, N, therefore vector B is, putting in B, Li, L is n by 3, or direct we keep equation of required line. So equation of required line is equation of required line which is passing from 1 to 3, 1 to minus 4. So its equation is vector r is equal to, from this given point, position vector of given point is 1i plus 2j minus 4k. This is vector A plus lambda times, say here vector B. Vector B is I add one more statement here, equation of required line passing from 1 to minus 4. So vector A is 1i plus 2j minus 4k. So required line here passing from this point. So this is vector A. Now equation of required line. See, in examination, whenever such questions are asked, if question is asked in 3 marks or 4 marks, then in subjective part you have to state all the statements properly with necessary words, necessary connection. Your work should not be like rough work. keep in proper sequence with proper words, then you will get full marks. So equation of required line is vector R is equal to vector A plus lambda times vector B. Lambda belongs to R. So vector R is, vector A is I plus 2j minus 4k plus lambda times vector B is Li plus mj plus nk. Lambda belongs to R, and now I am putting value of L and M as did in last question. L is n by 3, I plus 2j minus 4k plus lambda times L is n by 3, so n by 3 times I. M is n by 2, n by 2 times j, and n is n. Now simplifying inside here, taking here LCM 6 and n common, so vector R is I plus 2j minus 4k plus n lambda upon 6. 6 is LCM, so 2i plus 3j plus 6k. Lambda belongs to R. N is also real number. Lambda and n both are real numbers. N is also a real. So therefore whatever will be this number, it is arbitrary constant. It can be any real. So let me say this number is mu. So that is vector R is I plus 2j minus 4k plus mu times 2i plus 3j plus 6k. Mu belongs to R, where mu is for n lambda by 6. So this is required equation, vector equation of required line. Prove that if a plane has intercepts A, B, C and it is at a distance of p units from the origin, then 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square. Now see, equation of plane having intercepts A, B, C, we know that it is x by A plus y by B plus z by C equal to 1. That is, this can be written as x by A plus y by B plus z by C minus 1 is 0. Now its a distance from origin, that is 0, 0, 0. Its a distance from origin is a p units. So using distance formula, that formula p is equal to, so here RHS is 0. In this part we replace x, y, z by coordinates of that particular point. So putting here 0, 0, 0, so modulus of 0 plus 0 plus 0 minus 1 upon square root of 1 by a square plus 1 by b square plus 1 by c square. So that is p is equal to 1 upon square root of 1 by a square plus 1 by b square plus 1 by c square. That is, taking reciprocal, 1 upon p is square root of 1 by a square plus 1 by b square plus 1 by c square, and now squaring on both the sides we get 1 upon p square is 1 by a square plus 1 by b square plus 1 by c square. So this is derived. A line makes angles alpha, beta, gamma and delta with the diagonals of a cube. Prove that cos square alpha plus cos square beta plus cos square gamma plus cos square delta is 4 by 3. See here, it's a question of a cube, and we know that in any cube length of every side is constant. It is like a parallelepiped whose each edge has length equal, length A, and all angles are right angle. So here showing in this diagram, suppose that because we are working with vectors, everything you have to show clearly in this diagram, and diagonals we have to work in this question on the diagonals. So suppose I am taking here parallel and equal length, parallel and equal length, then join this side, parallel. So front side and back side, two parallel sides. Now joining these two corners, this should be parallel. Here, this side, so this is a cube. Now because we want everything in a 3 dimension, let me take this is origin. This line is positive direction of x-axis. This line is positive direction of y-axis. And this line is positive direction of z-axis. You can choose any line as OX, OY, OZ. It's not compulsory that I have taken this line as OX, so you have to take OX. You can choose this line as OY, this line as OX, this line as OZ. We can choose any line as a base because we are doing in 3 dimension. So base is required, that this is x-axis, this is y-axis, this is z-axis. Now we suppose that length of side of a cube is a unit. So if I put this point as A, because this length is A, coordinates of A will be A0, 0. This is a point on y-axis, this length is A, so coordinates of B will be 0, B0, A0. This is on z-axis, C, 0, 0, A. Now see, this point is on xy plane. It is on xy plane. Its x coordinate is A. Its y coordinate is also A. And in xy plane, its z coordinate is 0. Suppose this point is D. Now this point is on yz plane. On yz plane, so its x coordinate is 0, y coordinate is A, z coordinate is A. This point is in xz plane, so its x coordinate is A, y coordinate is 0 and z coordinate is A. And this point is, suppose we say this point is P. It doesn't lie on any plane. That means it's not a point on xy plane or yz plane or xz plane. It doesn't lie on any coordinate plane. So here it is in octant. So coordinates of P, it will be, say its x coordinate. If you imagine To find x coordinate of any point in the space, what we do? We take perpendicular from that point on x axis. So if you take perpendicular on x axis from this point, then perpendicular goes at this point. This will be perpendicular to x axis. So its x coordinate is a. Similarly, if you take perpendicular from this point on y axis, then it goes towards this side. So y coordinate is a. And z coordinate, similarly, taking perpendicular on z axis, this is z axis. If you take perpendicular, it goes in this direction. This will be put. So its z coordinate is also a. So take points as shown in diagram. Now here we have to work with the diagonals. So let us observe how many diagonals and which are diagonals. Diagonal in a cube, that means line segment joining opposite corners. See, this side bottom corner and opposite side upper corner. So upper corner, lower corner, joining these points, it is a diagonal. Don't join upper corner. Don't join lower corner. Join lower and upper. This is diagonal 1. This is diagonal 2. Similarly, diagonal 3. Diagonal 4. So 1, 2, 3, 4. So showing in this cube, first diagonal is O. Opposite to O point is P. So OP is a diagonal. OP. Because this is three-dimensional diagram, we are not drawing these diagonals. Otherwise, everything will be overlapped. So diagram becomes congested. So just imagine joining O and P. O and P are opposite. This side, this corner is O, opposite corner is P. So OP is a diagonal. So here OP is a diagonal. OP. Then opposite to B, a point is F. So BF is second diagonal. BF, OP, BF. Then say here. Now D, opposite to D, point is C. CD. CD. Then one more is left. EA or AE, opposite to A, this point is E. So EA or AE are diagonals. So OP, BF, then CD, AE. You have to imagine in 3 dimensions. Now we find direction cosines of these 4 diagonals. For direction cosines, what we do? We divide direction ratios by length of this line segments. So say here first of all we find length OP. So length OP is, by distance formula, length OP, or we can say magnitude of vector OP. So x1 minus x2 whole square, square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So this is 3a square. So therefore length OP is root 3 into a. Similarly, we can find a length BF. So if you use distance formula in these 2 points, then similarly we can find length BF, same root 3a. BF, a minus 0 whole square plus 0 minus a whole square plus a minus 0 whole square. Here OP is, I have done mistake here, I forget to put here square root sign. This is root 3a square. Similarly, BF is a minus 0 whole square plus 0 minus a whole square plus a minus 0 whole square, that is 3a square. It is BF square. So BF is again root 3a and CD is also root 3a, EA will also be root 3a. So all length of all diagonals, it will be same. So these are length of diagonals. Now direction cosines. Direction cosines of vector OP or line segment OP. So direction cosines of line segment OP are, say O, this is O, this is P. Direction cosines of OP. So a minus 0, divide a minus 0 by length. What is length? Root 3a, comma a minus 0, a minus 0, a minus 0. These are direction ratios, and direction ratios, if we divide by length, it becomes direction cosine. That is 1 by root 3 comma 1 by root 3 comma 1 by root 3. These are direction cosines of OP. Similarly, we can calculate direction cosines of BF are, say BF, this is B, this is F, say a minus 0 upon root 3a, that is 1 upon root 3, comma 0 minus a upon root 3a, that is minus 1 upon root 3, comma a minus 0 upon root 3a, that is 1 upon root 3. Direction cosines of CD. Direction cosines of CD are, now look, C and D, this is C, this is D. So see, direction ratios are a minus 0, a minus 0, 0 minus a, that is a minus a, a minus a, divide by length, dividing by length. So it will be 1 by root 3 comma 1 by root 3 minus 1 by root 3. Direction cosines of EA. Direction cosines of EA are, EA, this is E, this is A. So a minus 0, 0 minus a, 0 minus a. So a minus a minus a, divide by length EA. So it will be, say EA, here I am changing sign, changing order, AE, I am taking here AE. Line segment AE or EA is same, but because I am changing order, because I want a similar pattern. Otherwise, if you keep EA, it's okay. But AE, see AE, so E minus A, so 0 minus A, 0 minus A is minus A, minus A divided by root 3A, that is minus 1 upon root 3. Then A minus 0 divided by its length, so 1 by root 3, a minus a, a minus 0, that is a divided by length, that is 1 by root 3. So these are direction cosines of these diagonals. Now there is one more line which we have not drawn in this diagram, in this space. There is one more line. Suppose it can be somewhere here, it can be somewhere here, it can be somewhere here. It's not necessary that it will pass through this cube, not necessary that it will intersect this cube. It can be anywhere in the space. Suppose that that line is somewhere here. This is line L. Can be anywhere. This line is making angle alpha, beta, gamma, delta with her diagonals. So this line, it will make angle alpha with OP. With OP, it will make angle alpha. So here I am removing this diagram, otherwise it will be overlapping. We are keeping everything clear, whatever is necessary in calculation. So here, to explain the meaning of question, here this is O, this is P, this is OP. Now if this is a line L, so L will make angle alpha with OP. OP will be somewhere, this is the direction of OP. So it will make alpha. Then beta. Beta will be with BF. BF. So suppose that this point is B, this point is F. So this diagonal is BF. So with the diagonal BF, it will make angle beta. Like this. So there is a line other than these diagonals which we are not showing in this diagram. It is in a space. It can be intersecting, it cannot be intersecting. Somewhere in the space there is a line L which is making angles alpha, beta, gamma, delta with these diagonals. And suppose direction cosines of line, suppose that direction cosines of a line which is making angle alpha, alpha, beta, gamma and delta with diagonals. Now we take this sequence OP, comma, BF, comma, CD, comma, AE. Line is making angle alpha, beta, gamma, delta with these four diagonals respectively. And its direction cosines are, suppose L, M and N. So L, M, N are direction cosines of a line making angle alpha, beta, gamma, delta with this diagonals. Because these are direction cosines, so L square plus M square plus N square is 1. Now, this line having a direction cosines LMN is making angle alpha with OP. So cos alpha is modulus of, now see, these are direction cosines of OP, these are direction cosines of line. So by formula, cos alpha is L into 1 by root 3, that is L by root 3 plus M into 1 by root 3, M by root 3 plus N by root 3. upon, so here a1 b1 c1, these are a2 b2 c2. If these are direction ratios or direction cosines, then angle between lines is cos alpha is equal to a1 a2 plus b1 b2 plus c1 c2 upon root a1 square plus b1 square plus c1 square root a2 square plus b2 square plus c2 square. So this is equal to 1 by root 3 modulus L plus M plus N upon, this is 1 into 1, this is also 1 into 1. So modulus L plus M plus N upon root 3, this is cos alpha. Now see, beta is angle between line and BF. These are direction cosines of BF. These are direction cosines of that line. So similarly cos beta is, say, if we take a1 into a2 plus b1 into b2 plus c1 into c2, we will get term like this upon square root of a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square, but denominator values will be 1 into 1. So only the difference will be in sign. Here we will get minus sign. So modulus of L minus M plus N upon root 3 and cos gamma is, so consider these numbers. Similarly cos gamma is L plus M minus N upon root 3. Cos delta is, consider these numbers, minus L plus M plus N upon root 3. Now these values we are putting in left hand side of this required result. So the left hand side is cos square alpha plus cos square beta plus cos square gamma plus cos square delta. So this is equal to modulus of, now say cos square alpha, so cos square alpha, so square of this number, so square of modulus, square is always positive, so modulus will be removed, so that will be L plus M plus N whole square upon 3 plus cos square beta, so square of this number, L minus M plus N whole square upon 3 plus square of this number, L plus M minus N whole square upon 3 plus square of this number. Now I require space, so removing this side, so last value was L minus L plus M plus N whole square upon 3. Now simplifying this, 1 by 3 common. Now expanding this, L square plus M square plus N square plus 2LM plus 2MN plus 2NL plus this value is L square plus M square plus N square minus 2LM minus 2MN plus 2NL plus expanding this, L square plus M square plus N square plus 2LM minus 2MN minus 2NL plus this number, L square plus M square plus N square minus 2LM plus 2MN minus 2LN. Now you can see that this will be cancelled, opposite numbers. So what is left? It is equal to 1 by 3 times 4 into 4 times L square plus M square plus N square. But L square plus M square plus N square is 1. So 4 into 1. So this is 4 by 3. It is RHS. Therefore, cos square alpha plus cos square beta plus cos square gamma plus cos square delta is 4 by 3.